Okay, let's open R Studio first. I did. And tonight's chapter 5. It's about statistical assumption. When we do research, many cases now we use sample data. Then sometimes we are asking if it is normal, or if it is the data is valid for research. So when we use data for research, then we assume some things. So when we do using data, and then there are two types, like parametric and non-parametric. If we have data and then there is sample data, then using sample data for research, if we use the sample data to test the population. So if there is a population, then we call that parametric test. We don't care about the population, just using a sample and then sample itself, test the sample itself, then there is non-parametric test. So parametric test, one that requires data from one of the large distribution. So from a population, taking a sample, and then using sample, we test. Hey, Bart. Okay. So when we use sample data for research, then there are 4 basic assumptions. If it is normal distribution, and then if it is homogeneity of variance, interval data, and independence.
Yeah, hi, Dr. Kim. I'm sorry for being late.
It's okay. Thanks for coming.
Yes, thank you.
Okay. So sometimes earlier when I gave presentation about my research, then I asked now if my data is normal or not. Then usually we use certain method, then we can explain, like a 30 data size is 30 or more, and then we can assume normal distribution. So we use normal distribution, Z-score, and so on like that. So we will talk about normally distributed or not later. And then homogeneity. You know, from a population, we can take a sample, some of the sample, and then a second sample set, and so on. Then their variance, we assume, because their population is the same, then we can assume their variance or standard deviation is the same, because they are from the same population. And then sometimes, you know, take samples from different population, then we can compare. That case also, we can test if their variance or standard deviation is the same. So that is a homogeneity assumption. And the interval data, you know, the variable data, there are two types, qualitative and quantitative. So qualitative, another name is categorical variable. And then quantitative, another name is numerical variable. So you know, categorical, qualitative data, maybe that is not number. It's like a yes or no. So yes is not, yes, no is not number, but still data, right? So like that, that is qualitative data and categorical data. And then numerical data, numbers. Then there are two types of number, interval level or interval data, and then racial data. I will show you. Measurement of numerical variable. Numerical variable is quantitative data or variable, number. Then there are two types, interval data or interval level or racial level. Interval level, an ordered scale in which the difference between measurement is a meaningful quantity but does not involve a true zero. You know that for ladies, dress size, 1, 2, 3, 4, 5, like that. Maybe there is no zero size. And then temperature, there is 0 degree, but it's not a true zero. Something vague, but let's see. Racial level or racial data, this one also number, involve a true zero. Height, 0 is 0, nothing, right? From nothing to some point. So that is racial level or racial data. And then age, 0 is 0. But you know, Korean age and American age is different. When Korean are born, 1 year old, because Korean count the life start from pregnant. So when somebody asked me how old are you, then I said Korean age or the American age. So American age is younger. So I told them American age, 1 year younger.
Dr. Kim, what's your American age?
I will not tell. Anyway, and time, 0 is 0, right? Nothing, like that. Then why it is racial level? Okay, length, 50 inch, 100 inches. 50 inches is half of 100 inches, right? And then 100 inches is twice longer than 50 inch, right? We can, that number, we can use ratio. But like a temperature, 0 degree and 30 degree. Can we say 30 degree is 30 times hotter than 0 degree? No, because there is no true zero. Just intervally, same interval, we divide the same interval, then just that mean. It's not the ratio scale. So we call interval level if there is no true zero, and then ratio level if there is true zero, and then we can say twice, 3 times, double, and so on like that. So anyway, one awesome assumption is interval data at least, and then independence. If we have 2 variables, then we test like a correlation, then there is a relation dependent or not dependent, dependent or not dependent. But for our test, parametric test, if we take samples, then we assume they are independent. So we will talk about this independence later, but tonight I will talk about normality and homogeneity using R. Okay, by the way, normality, using this central limit theorem, we can explain from whatever population distribution shape, like bimodal, left skewed, symmetric, or right skewed, take more and more samples, and then 30 or more, then the samples distribution shape is normal. So this is a central limit theorem. If all samples of particular size are selected from any population, and then the sampling distribution of sample mean is approximately normal distribution. And then this approximation improves with larger samples. So that means take more and more sample, then sample shape is normal. So if population is normal, then any sample is normal, any size of sample. And then if the sample distribution is symmetrical, like this, even not shaped like a normal distribution, if it is symmetrical, left and right side the same, this one also, then if we take 10 or more sample, then we can assume sample distribution is normal. And then from any, like left skewed or right skewed, whatever population shape, take 30 or more, then we can assume sample is normal. So when we do research, and then regarding this data, so if we can take 30 or more sample size is 30 or more, then we can assume the sample is normal. Then we can use normal distribution for research. So when we determine if the data is for the research is valid or not, then the size of sample is 30. So we recommend for research 30 or more sample size. That is central limit theorem. And then normality assumption. So I mentioned earlier, for our research, many cases, we assume normal distribution. And then sometimes we ask it if it is normal or not. Then we can explain. If we can explain because of such, it is normal, we can assume normal. So by the sample size, we can say, we can assume normal if the sample size is 30 or more. And also there are two methods to explain if it is normal or not. Checking normality by using a chart visually. And in R and R Studio, we need a package, such package. So last time we used the ggplot2 package, but if you didn't save your last work, then you need to install this ggplot2 package again. So let's install one by one. Maybe later you need to install again, but anyway, to start tonight's chapter, we need those packages. So let's install them first. So first, I will install, if you can do it. So I will install ggplot first. Install. ggplot2. Nope. Wait. And then don't forget library, ggplot. Install and then like execute, that is library. Do it again. Okay. And then I will install car. In library, car. Good. And next one, past text. Good. And next one, psyche. So certain method need a certain package. Certain so different method need a different package. So we install then many packages. I'm done. I'm done. So if you install packages and then library, using library, execute packages, then say when. Okay, I will be back. Elia, what you drink now?
About what, Dr. Kim?
Drink.
What I'm drinking? I'm having green tea.
What's that?
Green tea.
Green tea.
Mm-hmm.
You
How
like
about you?
green tea?
Yeah, I love green
Coffee.
tea.
Coffee.
Okay.
I
That's
don't
the
like
reason you don't
green
sleep.
tea.
You don't?
No.
Okay. You're having coffee so late in the night. That's the reason you don't sleep.
I know. So I don't attempt sleep at night.
Right.
Whenever I sleepy, then I sleep.
Okay.
Like infant.
Mm-hmm. Mm-hmm. I do the same. So I feel you.
You know, especially during the break,
Mm-hmm.
summer break and then winter break.
Mm-hmm.
Just I live like a natural.
Mm-hmm.
So when I sleepy, then sleep, and then when I get up, get up. But you know, because I like play golf,
Okay.
then others want to play like morning.
Mm-hmm.
I don't like that.
Nothing in the morning.
if I play golf at night, then I will play better.
Okay. You should try doing that then.
Are you ready?
Not yet. 2 more to go.
Okay. I'm happy with my new computer. It's so fast.
Which one did you get?
HP.
Mm-hmm.
Hewlett
Nice.
Packard.
That's nice.
Yeah. Previously, I used Dell. Dell wasn't okay, but last like 20 years, I used Dell computers. But it's the first time, actually second time. Only this year I bought HP laptop, and then this time I bought HP desktop. So it is not very expensive, affordable price. Then the speed is good, memory size, and then so far I satisfied with that new computer.
That's great.
So mine is so fast, so
yeah,
that is good.
Mine is a Dell.
Dell also good computer. Okay.
So Dr. Kim, are these libraries predefined already in R or?
Say again.
Are these predefined libraries?
Yeah.
Okay.
Dr. Kim.
Yes.
Can I share my screen really quick? Oh, it says that you didn't enable share screen.
Yeah. I should make it let you share. Okay, you can do it now. Just a moment. I stop share first.
So I don't know. I got this pop-up window that says
updating loaded the package. Oh, no more of the package then will be updated. Yeah, yes.
Okay.
Then later, you know, when we use certain function in that package, then if we ask the package, then we can reinstall again. So don't worry.
Okay.
Okay, good.
Thank you.
Okay, you're ready, right?
Yeah.
Okay, I will share my screen again. Okay, checking normality visually, we can use histogram to look at the distribution shape. Then we can use just a regular R package, like a statistic package, then the same. But from last week, we use ggplot. This one is more powerful, the chart package or function. So we will use festival data. So first get that data using this read CSV. So I uploaded data for this chapter 5 in Google Drive. So I think you got the data and then save somewhere. So using, you know, every time we repeat again and again. I already did, but then do it again. So using a project, then bring data we need. So my data is in this directory. So I will create that project. So my data here. So first we will use this festival CSV file. So as you may know how to bring the data. So I will make name festival. Data set, then put in data set using read CSV function, and then the data set will bring in is festival CSV. So festival CSV. So check if we have the right data set. So festival. Then the data set looks like this. So kind of festival information, ticket number, gender, then day 1, day 2, day 3. Wow. This audience or this customer every day come and something like this. I think this one is like an this customer came to that festival and then stay 2 hours, 2.64 maybe time or something. So every day came. Not available means this customer come only in day 1 and then not day 2, day 3, something like this. So data size is 610. No, actually more, I think it's 800. So data size is 800. It's like the big data. So go back to PowerPoint slide. Using ggplot function, this one also make this kind of file data using this function. So this one is like plotting. So using ggplot, festival data, and then axis, day 1, using day 1 data, and then what kind of histogram draw. So using this function, histogram, using histogram, and then axis is y equals ... density. We may use this one like a line or something, but this time to see how many. So using density type histogram, and then outside the density bar color is black, and the fill inside white, and plus labels. X label is hygiene score on day 1, and then Y axis name is density. So let's try this using ggplot. Go back to so make like a file. File name is histogram, histo, day 1. Then put something. Draw a plot using ggplot. Open festival. From a festival data set, axis is AES. But I think ggplot package doesn't work. No. Let's try then. Add GEOM. I think it doesn't work. Try. ggplot package didn't install right, so I will install again. Install. Why it doesn't work? Install package ggplot 2. Yes. And do it again. Just copy and paste. Yes, it worked. Then if you type histo day 1, then you can see this plot. If you have this plot, then let me know. Looks like this, nice histogram. Pause. Yours working?
Yes, sir. No, I do not have my laptop with me right now. I'm actually traveling.
So just watching?
Yeah, I'm just observing. I'll probably get it done over the weekend.
So you know, you watching my error too. So if you have that error, then you can fix yourself.
Yes, correct. Plus the class is also recording, so that also helps sometimes.
Dr. Kim, I'm still getting the error.
Share your, can you share your screen? Okay. 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 After density, dot, only one closing parenthesis. Okay.
But then AES should also close, right? So it should be 2.
Let me see.
Oh, it doesn't close there. Okay, let me try. Okay, I think this works.
Histo day 1. And then, yeah, you got it.
Thank you.
How about others? Good. Okay. So from that plot, it looks like normal distribution, looks like. So middle, high, and then right and left, left and right side about the same. So looks like normal. Then to check if it is normal, we need another plot, kind of line plot. So using this, this one is for day 2. So try this one first. So histogram, draw histogram for data day 2, and then same. Others are same, but this data set different. So try this one. To compare. So I will copy and paste. I will type all again. Copy and paste, and then change only the data number. So day 2, and here day 2. This one, 2, and the same. And then enter. Then histo, A2. Then this one looks like right skewed, longer right side. Do you have the same?
Mm-hmm.
So earlier one looks like in a bell shape, but this one looks like in a right skewed. Earlier one, right, left and right, same size, and then middle high. And day 2 data looks like lower number side high, higher number side low, longer right tail. And then using next one, add the normal curve. So kind of the line. So we already made histogram day 1, and then plus such. Here, using stat function name is draw normal curve. And then argument list using mean and standard deviation, draw normal distribution line. And then so mean from festival data, day 1, standard deviation, festival data, day 1. And then this one, remove, not available. Go back to the data. Here, if the customer didn't come, then the data is not available. So not available, they are not the number data. So delete, remove this not available from the data to get mean and standard deviation. So using this function, remove not available, that is true. And then the same, remove not available. And then color of that normal curve, red, and then size, like that thickness is 1. So try this one. So already we have a histogram for day 1 plus add something. So stat, using stat, function. The function is draw normal curve not parentheses, argument equal list using mean equals mean using festival data, day 1, then remove not available, true. Then next, standard deviation equal standard deviation using standard deviation function. Festival, festival, day 1, and then remove not available and true. Then color, line color is red, whatever that you want. Size equal 1 and close. Let me see if I did right, hopefully. So we made this histogram and then add this normal curve using standard deviation and mean. Path.
Yes, sir.
You mean you are somewhere out
Yeah,
there?
I'm actually in Philadelphia right now.
Philadelphia? What do you do there?
I currently got hired as a business analyst over here. So I'm looking for a place to stay, and also I'm currently living with a friend of mine. And yeah, so I haven't actually moved from Scranton yet, but I'm looking for a place. So all my stuff is over there, so I kind of move back and forth over the weekends.
You know, usually people when go somewhere, every time bring a laptop. You didn't bring your laptop.
Yeah, mine's like a huge laptop, so it's really hard to travel with it.
You know, my new computer, the desktop, you know, size is about this big. So I said thickness is about 4 inches.
Right.
And then the size is like about this maybe 12 inches, 12,
right.
13 inches, so very small. So even it's a desktop, I can bring about this size.
I'm actually looking for a smaller laptop right now. For travel and all. But yeah, I have an iPad, but that won't do well.
Yeah. Okay, others, do you have this line? Got it? So from this line, go back to the screen. So a little bit kind of off from the line. but pretty much bell shape. So we can say from this visualization, we can say this one is looks normal. And then next, draw a normal curve for day 2. So I will do it the same as earlier. Just copy and paste and then change number. By the way, this one, after we done, this one shows something like a error sign, but this one is not error sign, something like a recommendation. So when we do this histogram, like second last in the lecture, when we do make the like a what is that, the bin class, then this one recommend the bin size is 30, but we don't need this. This histogram function automatically cut like this, and then this one nice. So we don't just don't care about this. Then histo, see, then change number 2. Done. So for day 2 data, draw this normal curve. Then looks like just we assumed. It looks like a longer right tail. You done? You have normal curve for both data. So we can see this one almost normal, and this one not normal from this visualization. Okay. Next one, now 8:05. So take a 5-minute break, quick break, and then continue. So I will be back 8:10. I'm back. Are you there? Okay. We used normal curve and see if it is in a normal shape. Then another plot using QQ plot. QQ means quantile and quantile plot. This one, earlier we talked about quartile. Quartile is like a divide the data set into 4 parts, 25%, 50%, and then 75. Similar, quantile is the proportion of cases we find below a certain value, like 50, less than 50, more than 50, and so on like that. And then graph plus the cumulative value. So from smallest to largest cumulative value plot. So using this function, QQ plot, actually function is this one, Q plot. This one is one of the function in ggplot2 package. So we don't need other package to use this function. So using qpplot, draw QQ plot for day 1 data. Then sample will be festival data, day 1, stat using QQ, and so on. And then label, X label is theoretical, and the Y label is sample. So using this function, try to draw QQ plot. So QQ plot. Put something in using qplot. Sample equals festival day 1 stat equals QQ plus label X equals Y equals warning message, but ignore, it worked. If it is error message, then something wrong, but warning message is kind of recommendation, so you can disregard. And then QQ plot day 1 looks like this. And then do it for day 2 data. So change number. Looks like this. So compare two data sets, QQ-plot. If we draw a straight line from the smallest to largest, then this one, those dots, not much apart from a straight line. Let me try draw a straight line if I can. Let me try using red. Let me try. I'm not sure if I draw a straight line. Using something. Here. Wow, it doesn't work very good. Let me. Yeah, it doesn't work. So anyway, if I draw a line like this, straight line, then they are not from apart from a straight line, but this one apart from a straight line, right? So if it is a perfect normal, then all data set on this straight line, but for a day 2 data set, many data apart from a straight line. So using this QQ-plot, we can determine if it is normal or not normal. And next, compare. Looks like normal, almost on the straight line. Looks like not normal, right, more right side and skewed. I assume if this one left skewed, then the curve looks like this. This one is negative exponential. If it is left skewed, right side high and left side low, then the QQ-plot line looks like this. Okay, then next. So far we check normality using graph. Then we can check normality using numbers. You know, in my class, one of my class that research methodology, when we covered the descriptive statistics part, Then I mentioned kurtosis and then skewness. So using R, find the numbers such median, mean, and so on, descriptive statistics. So using R, we can get those numbers. Then based on the number, we can determine skewness. If it closer to 0, then almost normal. Negative, then negative skewness, then left longer. Positive, then right longer. Kurtosis, if it is 0, then almost normal. And then positive, then high top, narrow. And then kurtosis is negative, then flat, and then wide. So we can use those function. Let's try. By the way, this function from this package, then this function from this package. So try this one, and then if it worked, then this package is installed, right? So let's try. Okay, describe. I think when we type something, the function, then if we can see already determined like this, then that package work, but this one doesn't work. So I need an install that package again. Okay, then let me see, describe. Yeah, describe, it works. So package installed on right. Then festival, day 1. And then stat describe. This one doesn't work. So maybe install the package again, test deck. Test decks. Okay, then yeah, now it's working. Then festival, day 1. Basic. If we use basic true, then short one. If we use normal true, then kind of long detail description. So false, then use normal, true. Something like this. So based on this, from this, the same. So whatever we can use. Then here, skewness, this one is 0, but here more detail, negative 0.0044. So almost a bell shape. And then kurtosis, negative 0.42. Little bit left side longer shape. No, I mean flat. Okay, next try day 2 data. So describe day 2. Day 2 data. Skewness is 1. Definitely right side longer, positive skewed. And kurtosis is positive, so a little bit narrow and then high shape. So using this description function, we can see the shape using number, skewness and kurtosis. And then using the same function, either describe or state description, we can get numbers for all data set. So using combine, nested function using combine, day 1, day 2, day 3, day 1, day 2, day 3. Then when we use state description, either way, basic output or normal output. So try to combine. So describe, combine. Festival, day 1, and festival, day 2, and festival, day 3. Looks like this. All 3 variables. And using stat, description, combine, then festival, day 1, festival, day 2, day 3, and then basic or not. First, try through this one. And Then normal force. Similar. Okay. This one doesn't show. If we use basic, then this one doesn't show skewness and kurtosis. So we need this one first. This one true. Then we can see kurtosis and skewness. So based on this output, we already talked about the day 1, day 2. Day 1, day 2. So skewness almost normal. Then day 2 and day 3, right skewed, longer right side. And then kurtosis, day 1, a little bit flat, but other day 2, day 3, narrow and then a high shape. So using number, we can determine if it is normal or not. And one thing more, you know, this output show many decimal points. So we can cut like a decimal point and 2 decimal point, 3 decimal point, and like that. So using this one, digits, decimal point, and 3 or 2, whatever. So I will copy. Just copy. Using round. Different function, but I will try if this one work. Round. And digits per 3. Yeah, work. So we can cut decimal point up to 3 digits. If we use 2, then 2 decimal point, and so on. Okay. You know, today's chapter is a little bit boring, right?
Not really. It was a little bit like the last time I saw the charts and stuff. So it's a little bit similar, but it's not boring.
You know, but this part, yeah, sometimes when I start today, it's important when we do research. Then if it is normal or not, then not always, but sometimes somebody asks you about your data, then normality or not, then you can say. So it's like you know, basic research basic. Okay, next one. Testing normality using Shapiro and Wilks test. It's like a hypothesis test. So using p-value, if p-value is greater than 0.05 significance level, so when we do research using data, analyze, then usually we use 0.05 alpha significance level. So if you use 0.01, then the kind of guideline is 0.01, but usually we use 0.05 alpha. So if p-value is greater than 0.05, then it's like, do not reject the null hypothesis. So we call non-significant. That case, like do not reject the null hypothesis, that means there is no difference. That means it is normal. If p-value is less than 0.05, based on alpha, the significance level, if you use 0.01, then less than 0.01. If you use alpha is 0.05, then p-value critical value is 0.05. Less than 0.05, then like a test result, reject the null hypothesis. That means there is difference. So if p-value is 0.05, less than 0.05, the distribution is non-normal. Greater than normal, smaller than non-normal. So using this function, Shapiro test, let's try. Shapiro test, then day one data, festival. P-value is 0.03. It's less than 0.05. In Shapiro test for day 2, p-value is very small, so definitely less than 0.05. So go back to, oops. Based on visualization, it looks like normal. And then based on number, looks like normal, but a little bit, based on the kurtosis, little bit flat. So by test, we can determine the day one data also not normal. But this W value, if it is 1, that is normal. 0.995, almost normal. So by p-value, we can say it is not normal, but by W value, we can say it is almost normal. This one, second one, day 2 data, definitely not normal, and then 0.90, far from 1. So based on this W value, it is not normal. So we can use other data, then we can determine the same, but I will skip this one. We did, this one is like in a practice. Okay, then homogeneity test. Using this function, from a CARB package, then if the value, we call that F value, the same, if it is greater than 0.05, then not significant. If it is less than 0.05, significant. Greater than 0.5, then homogeneity is true. If it is less than 0.05, homogeneity is not true. So let's try exam data. So I need the exam data, so I will bring exam data and then I will test. Just look at it. I will do it now fast. Exam data. Put in with CSV. Then from this data set, exam exam data. So exam data looks like this. So there are two university. So indicate by 0 and 1. So two groups, 0 group and then 1 group. So compare two groups. If they are from the same population, that means if their variance are the same, standard deviation is population standard deviation or population variance are the same. Using this Levene test. So when we use this Levene test, L-E-V-E-N-E test, oops, it doesn't work. So I need to install that CAR package again. Okay. Library. Library CAR, execute first, and then it worked. Levene test, and then exam data. At that exam data, I will use exam score, compare two groups. The group in exam at university or unit. So different unit, 0 unit group, 0 and 1. compare, error. Levene, not that test, just the test. Then exam. Exam. What? Test. Slope. Exam. Add. Exam data. Compare by group. The group information is exam in exam. At uni. Column. Done. Okay, so the F value, PR F value is 0.150616. This one is greater than 0.05. So not significant, not significant. So two groups, 0 group and one group, two groups, population variance are the same. So we can say this data from two groups data, their homogeneity is true. So we can determine their population variance are the same. So we can use this Levene test if it is homogeneity or not. So you know, until last time, we did how to install R Studio, and then how import the data, and then how show data using number, and then using a graph. And then from today, I cover some statistical method. So, you know, statistics using R. So my lecture is based on statistics and then using R. So mainly I cover statistics, techniques, tools, and so on. So statistics, we need statistics for research, data analysis. So today's part is one of the basic parts of data analytics, research, normality, homogeneity, and so on like that. So it's, I say a boring part, but sometimes it is a very important part. So I covered. You know, because this one is kind of my special lecture for you. If it is like an undergraduate stat class, I don't cover this part. Because you are an upper master level student, so it's like a practical. In real world, you do research, you analyze using data in real world. So in real world, sometimes you need this part for your research. So I cover this part and using R. Of course, no. We can use Excel. We can test that normality, homogeneity, and so on. But this class is statistics using R. So I show you using R how to test normality and homogeneity like this. Okay, that's all I prepare for tonight. If you have a question, do you have a question or not? Okay, not, then that's all, and see you next week. Next week, Thanksgiving, right? So let's make no class. So like a break, and then see you 2 weeks later for this class.
Okay, thank you. Thank you, Dr. Kim.
Okay, thank you. And see you later.
Dr. Kim, good night.
Thank you, good night.
Thank you, Dr. Kim. Have a good night.
Thank you, good night.